Okay, regarding the rate of reaction, no? Okay, so if your school haven't conducting your chemistry exam, okay, so you can get ready. We do some revision here. Okay, diagram 7 shows two experiments to investigate one factor okay, that affect the rate of reaction between the zinc and the hydrochloric acid. Okay, huh? So you can see zinc is excess. This one zinc granules, ketolan or butiran is a big size one. Okay, so same size. Okay, this is the volume. Volume, this is 50, this is 25. Okay, so volume, is volume one of the factor? No, volume will not affect the rate of reaction. Huh? Okay, but this one, 0.5, okay, mole per cubic decimeter. This is the concentration. Here is 0.5, this is 1.0 mole per cubic decimeter. Okay, so meaning that we know that the concentration is different here. So the factor now is the concentration of acid. Okay, concentration of acid is the factor. Huh? Okay, now you see 0.5, 1.0 for set 1 and set 2. So higher concentration, higher rate of reaction, right? So set 2, we know this is higher rate of reaction. Okay, we can record first, because higher concentration, right? So this one lower rate, lower concentration, lower rate of reaction. Okay, so lower rate of reaction. Okay, so you can write first up like this. So you release the hydrogen gas, Now, okay, how to determine the rate of reaction in this experiment? How do you determine the rate of reaction? Okay, we measure, right? We measure what? We measure the volume of hydrogen gas, right? Okay, volume of hydrogen gas released per unit of time. So the volume of hydrogen gas released divided by time. Okay, so this is the rate of reaction based on this experiment. Okay, huh? Now, V, the maximum volume of hydrogen gas released in experiment 1 is V cubic centimeter. Okay, V. Now, what is the volume of hydrogen gas released in the experiment 2? Okay, so experiment 1 is V, experiment 2, okay, compared to experiment 1, then you need to explain your observation. Okay, so class, for this one, let's go back to our question here. Okay, so zinc is the excess already, so we no need to see this one. So we will see the limited one. Okay, so class, we need to find, if we want to find the volume of hydrogen gas, so we need to have the mole times the molar volume, right? Okay. So class, what is the number of mole for this acid first? So first we can write out the chemical equation first. So hydrochloric acid, this one you can record down, react with zinc. So it produces zinc chloride and the hydrogen gas. And this one times 2. Okay. So we have MV over 1000. So we calculate the MV over 1000 first. So can you calculate the number of mole using this formula? IV or Suyang, can you calculate it? What is the value? Use your calculator. Can you calculate? MV over 1000. It's the number of mole. Suyang, have you calculated? Or Ivy? 算到了吗? So we can calculate. Okay. M molarity is 0.5. V is 50 over 1000. Okay, so you will get MV over 1000. So what is the value? Okay, 0.025. 0.025 mole. Okay. Now for the volume of gas here, so we need to compare the acid with the hydrogen gas. So this one is 2, this one is 1, right? Okay, so we do the mole ratio, right? Okay. So 2 mole of hydrochloric acid produce 1 mole of hydrogen gas. Correct, huh? Then how about this 0.025 mole of hydrochloric acid? How about the oxygen, hydrogen gas? 2 to 1 means half, right? So this one becomes divided by 2, 0.0125 mole. Okay, huh? So number 3, volume of hydrogen gas. So 0.0125 mole times the molar volume 24. So you will get so you get 0.3 cubic decimeter. Oh, then the questions mentioned this is V cubic decimeter. Is it V decimeter? Cubic centimeter. Centimeter meaning that not cm3. So if we want to get cm3, you want to get the cubic centimeter, meaning that we need to times 1000, times 1000. Okay, times 1000, you get 300 cubic centimeter. This is V cubic centimeter. Okay, so this is for experiment 1. Experiment 1. Then how about the experiment 2? So if experiment 2, okay, same method, we can calculate also. So we use the MV of 1000. So MV. So we want to see whether the mole is the same or not. So 1.0 times 25. So over 1000. Okay. So 1. Okay, you'll get 0.025 mole also. Yeah. So 0.025 mole, these are also 0.025 mole. So in other words, the volume of the number of mole of the acid here will be the same, So if you ratio it will be the same, then the volume will be the same. Okay. So in other words, class, if you see the number of mole for the acid are the same. Okay. If the number of mole for the acid are the same, meaning that the volume will be the same. Okay. Volume will be the same. Yeah. So this one you can record down. So meaning that your answer will be the same. That is the V cubic centimeter. Okay, will be the same. Okay, why? Okay, just now we calculated already. The number of mole for hydrochloric acid in both experiments are the same. Okay, the number of mole. So you can record down here. We use the MV over 1000. Okay, you get 0.025 mole. Okay. Any question? Can understand or not? Okay, next. Now the graph of the volume of gas against the time for experiment 1. Experiment 1. Okay, is sketched as shown in the graph here. Okay, now sketch the curve for the experiment 2 on the same axis. So class, for the experiment 2, we know it has a higher rate of reaction, right? So in other words, the gradient is steeper, right? So steeper gradient. Okay, but the volume are the same. So you can sketch the graph. So steeper the gradient, but the volume are the same. V. So you can sketch it like this. This is a straight line now. So this is, you need to label, this is experiment 2. Okay, experiment 2. Any question? Can follow or not, class? Yes, huh? Okay, so you get the graph like this, same. Experiment 1 and experiment 2. Oh. Okay, you can use this one to be the same. Okay, now based on the diagram, which experiment has a higher rate of reaction? So experiment 2 or experiment 2. So referring to the collision theory, explain how the rate of reaction in experiment 1 and experiment 2 is different. They are different. So the factor now is the concentration of the hydrochloric acid now. So first, the concentration of hydrochloric acid in experiment 2 is higher than experiment 1. Then number of hydrogen ions per unit volume in experiment 2 is higher than experiment 1. Then frequency of collisions between hydrogen ions and zinc atoms in experiment 2 is higher than frequency of effective collision in experiment 2 is higher than experiment 1. Okay, so it has a higher rate of reaction. Okay, done already? Okay, this one you can mention in here. But actually, if you mention this one in point number 3 already, then you can skip this one also. Oh. Okay, now we look into table 6. Table 6 shows 3 experiments carried out by a student. Okay, now A, B, C. A, calcium carbonate chips and 25 and 25 cubic centimeter of 1 mole per cubic decimeter hydrochloric acid. Okay. Now you see here, okay, calcium carbonate chips. All are chips. There should be no problem. Okay, now this one concentration 1 mole per cubic decimeter. This is 0.5. This is 0.5. Okay. So class A, B, and C, which one has the highest rate of reaction? Which one highest rate of reaction? A, B, or C class? Which one higher rate of reaction? Highest. Siyang, Ivy, which one? A, B, or C? Highest rate of reaction. Okay, A. Why? Why A, Ivy? The answer is correct. It's A. Okay, this one highest rate of reaction. Okay, why? Higher concentration of hydrochloric acid, correct? Okay, because this is highest. Then B and C, same concentration, same size. How about the rate of reaction? If same, no factor affecting, this one same rate of reaction, same rate of reaction. Okay. Then these two, what is the difference? Here, the number of mole different, the number of mole. So we can calculate the MV over 1000. This one lower, this one higher. Okay. So alang here already. So we can calculate the number of mole first. Okay. So we use the MV over 1000. MV over 1000. Okay. IV you calculate for experiment A. What is the number of mole? Siyang you calculate for B, experiment B. What is the number of mole? Mole, MV over 1000. Okay. C, I will calculate for C. Okay. So once you have calculated, you can write your answer. You can type your answer here. So A is 0.025. Okay, IV already. 0.025 more. Okay, Siyang, how about yours? Okay, for C is 0.05 more. Okay, Siyang, how about yours? MV over 1000, what is the number of mole? For the acid, for the acid. Siyang? Mole, 0. M molarity, so times 25 over 1000. Okay, so what is the number of mole? Okay, so you get 0.0125 more. Okay. So we have the mole already, then the volume of gas. Okay. So we know already. So experiment A, highest rate, so the gradients differ. Okay. This one very simple to determine. If the mole is higher, okay, these two same, right? B and C the same. So if the mole is higher, meaning that the volume is higher because the volume of gas equals to mole times the molar volume. Right? So here, number of mole for C is higher, correct? So this one lower. So in other words, the higher one, same concentration, right? They have same concentration. But the volume of the gas, carbon dioxide gas, for C is higher, right? So this is experiment C. Then the lower one will be experiment B. Okay, how class? This is B, this is the C, the volume of the gas collected are the same. Okay. Just need to be careful, especially when this kind of question. So let's say hydrochloric acid react with calcium carbonate. So you produce the calcium chloride, carbon dioxide, and water, right? So this one, you need to balance the equation. So this one times 2. Okay. So class, when you calculate for the acid, right? So let's say for experiment A just now, A, 0.025 mole. This is 0.025 mole, right? But this is for 2 moles. So when you want to find the volume of the gas, so the ratio is 2 to 1. Okay, 2 to 1. So in other words, the 0.025 meaning that this one is 0.0125 mole only. Okay, So more for the carbon dioxide for set A, set A. So times the molar volume 24. So you will get 0.3 cubic decimeter equals to 300 cubic centimeter. Okay. So meaning the air will be 300 cubic centimeter. Okay. So don't use this one directly. Remember, you need to do the mole ratio. Mole ratio. This is 2, this is 1. Okay. Especially when you want to calculate the volume of gas. Always remember. Okay. Mole ratio. Okay. Next. This is essay question already. Essay question. Okay. So it shows the two situations of grilling 500 grams of the meat. So based on the diagram, which situation meat will cook faster? Which situation it will cook faster? Hello, Darren. Okay, now we are talking about this Terengganu questions. Okay. So situation A. Okay, good. Situation A. The meat will cook faster. Okay, correct. Now state the factor that affecting the rate of cooking the meat here. Why you mention this is situation A? Larger total surface area. Okay, the size factor or the total surface area, or you can mention size of meat or total surface area of meat. Okay, so this is the factor. So 2 marks. So 2 marks. Okay, now B. Table shows the information about the reactants and the temperature used in 3 experiments to study the, the factor affecting the rate of reaction. So reaction between the calcium carbonate and hydrochloric acid produce the gas X, which make the lime water cloudy. Yeah. So this one just now we discussed already, So hydrochloric acid react with calcium carbonate, produce a calcium chloride, carbon dioxide, and water. This one times 2, okay. So the gas here will be the carbon dioxide gas, Okay, now we look into the 3 experiments, 1, 2, and 3. Okay, first we check the sizes. Calcium carbonate chips. This one also chips. Also this chips. So size is not the factor because the same size. Okay, second one we check the concentration. 0.5, 0.5. This one 1. Meaning that this one higher rate, higher rate. Okay, but this one temperature we have to check also. 35, 45, 45. Yeah. So this one faster reaction, higher rate of reaction, faster reaction. Okay. And if 2 and 3, 2 and 3 is the factor of concentration, right? Yeah. So the question definitely will mention, ask you to compare 1 and 2. That one is 2 and 3. Yeah. So this one the factor is temperature. These 2 and 3, the factor is the concentration of hydrochloric acid. Okay. So the time taken to collect the 50 cubic centimeter of the gas. 50 seconds, 30, 20. So meaning that this one highest rate. Second one is this one. Sorry. Let me check. This one higher temperature, so higher rate. So this one highest rate, step 3 highest rate. This one second. This one lowest rate. Okay, Now name the gas X. So gas X is the carbon dioxide gas now. What is mean by rate of reaction in this experiment? So it's a change in the quantity of reactants or products per unit of time. The gas X is carbon dioxide gas. Carbon dioxide gas. Okay, so 2 marks. Okay. This one you also can write change of volume of carbon dioxide gas per unit time. Also can. Okay, now calculate the write the chemical equation. Just now I write already. Okay. Okay, calculate the maximum volume of carbon dioxide gas produced in the experiment one. Experiment one. Okay. So 5 marks. Chemical equation will be 2 marks. Calculation 3 marks. Okay. So I would like you to try this question. Just now I explained already, huh? So you try to do this round. Okay, I give you 5 minutes. Okay, now we check together, class. Okay, so first chemical equation, just now I also showed to you already. So this one 2 marks. Correct formula for reactants products 1 mark, and then balancing 1 mark. So 2 marks. So next we calculate the number of mole, MV over 1000. Okay, so 0.015 mole. Okay, so for hydrochloric acid now. So here. Next, don't forget, just now I also mentioned to you, need to do the mole ratio. 2 mole of hydrochloric acid produce 1 mole of carbon dioxide. So if 0.015, so it's 0.0075 mole of the carbon dioxide. Okay. Then you have the number of mole for the carbon dioxide already. So times the molar volume, 24. So 0.18 cubic decimeter. Or if you want to change to cubic centimeter, times 1000, so 180 cubic centimeter. Also can, both can be accepted. Okay, so 5 marks, 5 marks. Okay, correct, class? Okay, now calculate the average rate of reaction for experiment 2. So experiment 2, okay, the volume is what? Volume is 50, right? 50 cubic centimeter. So the time taken is 30 seconds, right? 50 over 30, so 1.67 cubic centimeter per second. Okay. So 50 is given in the question, In the question. Okay. Now compare the rate of reaction between experiment 1 and 2, and then experiment 2 and 3. Explain your comparisons with reference to the collision theory. So 10 marks. Meaning that this comparison, 5 marks. This comparison, 5 marks. Okay. So each point, each comparison, you need to write 5 points. This one also 5 points. Based on the collision theory. Okay, so 10 marks. So I show to you. Okay, so 1 and 2 is a factor of temperature. Okay, 2 and 3 is based on the concentration of the hydrochloric factor, hydrochloric acid factor. Okay, so now I like you to try also to write the comparisons using the collision theory. Okay, so the clue you can do like this. Experiment 1 and 2. Okay, so 5 points. Experiment 2 and 3, then another 5 points. So this one I let you to try first. You can refer to the notes, okay, in our class. So you can, based on there, you can write the points correctly. So 10 marks. So if your school exam, so you have to get ready. In SPM also the same actually. So you try to write the points. Afterwards, we check together. Okay, class, now we check together. So experiment 1 and 2. So first, you can mention the rate of reaction in experiment 2 is higher than experiment 1. At this point, you can write at the last point also can. Yeah, so it's up to you. So I write first. So we directly go to the factor. Temperature of experiment 2 is higher than experiment 1. So if temperature higher, so the kinetic energy of the particles in experiment 2 is higher than experiment 1. So we mentioned about the kinetic energy. Then frequency of collisions, okay, between the hydrogen ions and calcium carbonate. So this one, you have to mention it. Calcium carbonate, no need to mention what particles it is. Directly use the name, the whole name, calcium carbonate. Okay, is increased. Then the frequency of effective collisions between the hydrogen ions and calcium carbonate in experiment 2 is higher than experiment 1. Okay, so 5 marks. Yeah. So you can see 0.4 and 0.5 only difference of these effective collisions. And this one no effective. Oh. Okay, no? Now experiment 2 and 3 is a factor of concentration, right? So experiment 3 has a higher rate of reaction than experiment 2. So the concentration of hydrochloric acid in experiment 3 is higher than experiment 2. So the number of hydrogen ions per unit volume is higher in experiment 3 than experiment 2. Okay, 4 and 5 are the same. Okay, frequency of collisions and frequency of effective collisions. Okay, so total 10 marks. 10 marks. Okay, class. Next, we look at this question. Essay question also. A diagram shows two water temperature options available on the washing machine. This is hot water, cold water. Okay. Now, based on the diagram, which water temperature option can be clean, cold faster? Explain your answer. So 3 marks. So first one, okay. So I think option hot water, right? Okay, hot water. Okay, why? So temperature of hot water is higher than cold water. And kinetic energy of water molecules in hot water is higher than the cold water. Okay. Now number 2, state 2 other factors that can affect the rate of reaction other than the temperature. So besides the temperature factor. So what are the 2 factors? Another factor. This one, size of the reactants. Okay, number 2, concentration of the reactants. So 2 other factors affecting the rate of reaction. Okay, next. Okay, we look into B. A student carry out 3 sets of experiments to investigate the factor that affects the rate of reaction between the magnesium and sulfuric acid. So magnesium and sulfuric acid. So the gas produce 30 cubic centimeter of gas. So here we know that the magnesium react with acid. So what is the gas produced? So roughly we can draft out sulfuric acid. So it produces a magnesium sulfate as a salt, and then the gas will be hydrogen gas. Hydrogen gas. Oh. So the gas collected here will be the hydrogen gas or hydrogen gas. So here we can see this is using the sulfuric acid now, sulfuric acid. Okay, concentration 1. This is powder, huh? Okay, now step 2. Sulfuric acid also same concentration. Okay, now it's the granules, granules. Okay, these are also granules, but this one higher concentration. Okay, now set A, set 1, 2, and 3. 1, 2, and 3, yeah? So we know that time taken, this one highest rate, no? Step 1 is second one. Then step 2 will be lowest rate. Okay. This question actually almost the same as this one. So this one I will also let you try, but this time I think you can do it faster already, huh? So you can do the calculation now. 5 marks. Huh? So chemical equation will be 2 marks. Calculation will be 3 marks. So total is 5 marks. So quickly you try to calculate now. Okay, class. Now we check together. Okay. First, write the chemical equation. So just now I showed to you already. Okay, so magnesium with sulfuric acid produce a magnesium sulfate and hydrogen gas. Oh, so this one 2 marks. Okay, next, we can calculate the number of mole for sulfuric acid, MV over 1000. So 0.04 mole. Okay, now here 0.04. The mole ratio is the same, right? 1 mole of sulfuric acid produce 1 mole of hydrogen gas. So this one will be the same. So 0.04 will be the same. 0.04 mole of hydrogen gas. Okay, then volume of gas. So mole times the molar volume, 0.96 cubic decimeter, or times 1000, so 960 cubic centimeter per second. Okay, now compare the rate of reaction between step 1 and step 2, step 2 and step 3. Okay, again, I think this time I will also let you try step 1 and 2. Let's see, step 1 and 2, what is a factor? So class step 1 and step 2, what is a factor affecting the rate of reaction? Class 1 and 2, powder and the granules, right? Okay, so meaning that it's the size, right? 2 and 3. 2 and 3 is the concentration, right? Concentration of sulfuric acid. So this one, you quickly write out the 5 points for set 1 and set 2. Then set 2 and set 3, another 5 points. Okay, quickly, yeah? You write out this. Okay, we check together. So set 1 and set 2, rate of reaction of set 1 is higher than set 2. Okay. So size of magnesium in the set 1 is smaller than the set 2 because it is using the powder, right? So remember, if powder, smaller size, remember. If smaller size, the total surface area for magnesium is larger in set 1 than set 2. Okay, so don't forget the word total. Don't just write surface area. You must write total surface area. Then the frequency of collisions are between the hydrogen ions from the acid and the magnesium atoms in set 1 is higher than set 2. Then point number 5, what is the difference? I think you should remember effective collisions. Okay, the only words difference is the effective collision. Okay, correct, Natas? Okay, now set 2 and set 3. The rate of reaction in set 3 is higher than set 2. Okay, why? The concentration of the sulfuric acid in set 3 is higher than set 2. Okay, if the concentration is higher, the number of hydrogen ions per unit volume, you have to mention these words, these points. Okay, in set 3 is higher than set 2. Okay, then 4 and 5 are the same. Frequency of collisions is higher than set 2. Frequency of effective collisions. Yeah, again, the same particles you have to mention. correctly. Okay, class, you may ask, just now I mentioned already, huh? So if here I just write particles can or not, try not to, because we mark separately, separately. So you have to mention hydrogen ions and magnesium atoms for set 2 and set 3, set 2 and set 3. Okay, now we continue. Okay, to the Klandan questions. Okay, class, you can see the questions always asking you the factors, right? Here is what the meat is cut into the smaller size to cook, right? So this is a factor of size, right? So state the meaning of rate of reaction again. So it's a measurement, the change in the quantity of the substance or the result of the reaction per unit of time. Okay, now number 2, based on the conversation, state one factor affecting the time taken. So just now is a meat size, right? Okay, or size or total surface area. Okay, explain your answer. The smaller the size of the meat has a larger total surface area. Okay, then the meat can absorb more heat in a shorter time, shorter time. Okay. Next, again, there are 3 experiments here. You can see almost the same. Always check temperature. This one higher temperature. Okay. This one shortest the time, meaning that this one highest rate, this one second, this one lowest rate of reaction. Now we check why this one lowest rate. Let's see. Zinc maybe zinc strip. Zinc strip the same. Concentration 2.0, this one 2.0, this one 2.0. But here we have this one, copper 2 sulfate solution. So class, what is this? What is this copper 2 sulfate solution? What is the function of this class? Anyone know? What is the function? As what? Okay. If you see like this, suddenly appear one extra chemical. So this one as the catalyst. Okay, as a catalyst. Okay, so later you need to compare. You will need to compare set 1 and set 2, and set 2 and set 3 again with set. Okay, keep repeating, right? So calculate the maximum volume of hydrogen gas released. So 3 marks. I previously asked you to write the chemical equation, right? Plus this calculation. So this one given to you the chemical equation already. Asked you to calculate the maximum volume. So number of mole we discussed already. We calculate the number of mole. MV over 1000, right? Okay, you get 0.01 mole. Okay, so for acid, we need to compare, compare with hydrogen gas. So 2 moles of hydrochloric acid produce 1 mole of hydrogen gas. So if 0.01, half, right? Divide by 2, 0.005. So can you find the number of mole? Can you find the volume? Yes. Mole times the molar volume. So you get 0.12 cubic decimeter. Yeah. Okay. Now sketch the graph for the volume of gas against the time taken for the experiment 1, 2, and 3 on the same axis. Okay. Mm. So this one, I think if you are asked to sketch the graph, okay, try 3 marks. Okay, the clue here, first you need to find the factor. It will determine the gradient, okay, of the curve. Okay, number 2, you need to find the volume, the number of mole. You will need the number of mole, find the volume of gas. Yeah. So you try. Okay, now we check. Okay, so first we need to see the factor to determine the gradient of the curve. So now we look into this one. Okay, so meaning that set 3 highest rate, right? So meaning that the gradient will be the steepest, right? Okay, then set 2, this is set 3. Then is set 2, this is set 1. Okay. So now number 2, you need to find the volume are the same or not. So what we need to calculate? We need to calculate the number of mole. So we use the MV over 1000. So M is 2, V is 5 over 1000. 2, 5, 2, 5, meaning that for 3 sets of experiment. In other words, the height of the volume of gas are the same. Okay. So 1, 2, 3, same volume of the gas collected or released, but the rate of reaction is different. So the sketch of the graph will be like this. 1, 2, and 3. Okay, correct or not, class? So you need to label here. Don't label here. If you label here, actually 1, 2, 3, they all stop at the same volume here. So you don't label here. You label it at the 3 different curve here. Okay. Any question you want to ask? All can understand, huh? Anything you want to ask? Okay, next question. Explain, compare the rate of reaction again now. This time, 1 and 2 is the factor of temperature. So temperature we have right already. So directly we can discuss. So the rate of reaction in experiment 2 is higher than experiment 1 because the temperature in experiment 2 is higher than experiment 1. Okay. So temperature higher, meaning that the kinetic energy of the zinc atom and hydrogen ions in experiment 3 is higher than experiment 1. So frequency of collisions between the hydrogen ions and zinc atoms in experiment 2 is higher than experiment 1. So frequency of effective collisions between the hydrogen ions and zinc atoms in the experiment 2 is higher than experiment 1. Okay, so this one factor of temperature. So this one we have learned already just now. Okay, but 2 and 3 now is a factor of catalyst. You haven't tried this now. Okay, so these 5 points, you try to write the 5 points. Okay, I give you some times, few minutes. You try to write out the 5 points for the catalyst factor. Okay. So experiment 2 and 3. Experiment 3, it has a catalyst, right? So rate of reaction in experiment 3 is higher than experiment 2. So we focus to the experiment 3 because it has a catalyst. So experiment 2 use the carbon 2 sulfate solution as a catalyst, while experiment 2 has no catalyst. So the catalyst provides an alternative route or pathway with lower activation energy in the experiment 3. Okay, then for this one, no need to mention about the frequency of collisions. Directly we mention about the effective collisions, right? Okay. More collisions between the hydrogen ions and zinc atoms achieve a lower activation energy. So frequency of effective collisions between the hydrogen ions and zinc atoms is higher than in the experiment 3 than the experiment 2. Okay. So this one, the points, point 4 and point 5 is slightly different with the other factors, right? Other factors like this one, 4 and 5, just the difference of this one word effective collisions. Okay. But this one, point number 4, more we mentioned about the collisions between the particles, hydrogen ions and zinc atoms. It can achieve a lower activation energy. That is the only difference. Okay. Now, next question. Okay, question number 10. Okay. Diagram shows a coral reef found in the Cebu Island. These coral reefs are formed from the salt Z. So state the meaning of the salt. Okay, and then name the insoluble salt. So what is this actually? Okay. So actually is the meaning of the salt is a compound form when the hydrogen ion from the acid is replaced with the hydrogen ions from the acid, okay, replaced with the metal ions or ammonium ions. Okay, then insoluble salt. Example, lead to chloride, lead to sulfate, or any correct insoluble salt can be accepted. Step 1, one insoluble salt. Namakan satu. Okay, next question. A diagram shows the apparatus for the reaction between hydrochloric acid with the solid of salt Z. Okay, so salt Z, you can see it turns the lime water to cloudy. So what is this gas? With carbon dioxide, right? So if here we have calcium, so meaning that this one is a calcium carbonate, right? Okay, so calcium carbonate. So the gas released will be carbon dioxide gas. So 2 marks. Okay, next. You can see experiment 1, 2, and 3. You can see the pattern are all the same. Okay. Temperature 30, 30, 40, higher temperature. This one 20, 12, 10. So this one highest rate, this one second, this one lowest rate. Okay. So later, again, you will see let me see. Sulfuric acid. Okay. We double check. Sometimes the question get 20, 0.1 sulfuric acid. This one got the catalyst. Okay. This one as the catalyst. catalyst 0.1, this one 0.1 powder. I think this one should be highest rate because it has the catalyst. Oh, this one no catalyst, zinc powder, sulfuric acid, zinc powder, sulfuric acid. Okay, these two. This one highest rate. Oh, this one highest temperature, huh? Highest temperature, higher temperature. Okay. Okay. This one lower temperature. Okay. Yeah. If like this, with higher temperature. So later you will see the comparison will be 1 and 2. Another one will be 1 and 3. Okay. So these two is the factor of catalyst. These two, 1 and 3, will be factor of temperature. Okay, huh? So now write the chemical equation. Okay, zinc and the sulfuric acid. Okay, this one we try also just now. So this one 2 marks. Now average rate of reaction for experiment 1 and 2. Experiment 1, volume is 30, 30, time is 20. Okay, so 1.5 cubic centimeter per second. So for experiment 2, 30 over the time is 12 seconds. So it's 2.5 cubic centimeter per second. So another 2 marks. Okay. Now sketch a graph of volume against time for both experiments in the same axis. So it will be 1 and 2, 1 and 2. So 2 higher rate of reaction compared to 1. Okay, so this is the, the graph. The volume level with the unit must be stated. This one times, this is seconds. Oh. Okay, so last question. Okay, based on the table, compare the rate of reaction 1 and 2 and 1 and 3, right? So in each case, state the factor affecting the rate of reaction and explain the difference in the rate of reaction with the reference to the collision theory. Okay, so again, okay, 1 and 2 and 1 and 3. Okay, so this one, I think we already discussed this now, so we can directly refer or we can directly discuss together. Okay, so 1 and 2 first. So the rate of reaction in the experiment 2 is higher than experiment 1. Okay, so the catalyst is present in the experiment 2, but not in experiment 1. So catalyst will lower the activation energy in the experiment 2. So more colliding hydrogen ions and zinc atoms can achieve a lower activation energy. So frequency of effective collisions between the zinc atoms and the hydrogen ions in experiment 2 is higher than experiment 1. Okay, so this is a factor of catalyst. Okay, 1 and 3. 1 and 3 because of the temperature. So rate of reaction in the experiment 3 is higher than experiment 1. And temperature of the experiment 3 is higher than experiment 1. So if higher temperature, so kinetic energy of the particles in the experiment 3 is higher than experiment 1. So more colliding particles can achieve the activation energy. So frequency of collisions between the hydrogen ions and zinc atoms in experiment 3 is increased or higher than experiment 1. Okay, now frequency of effective collisions between the hydrogen ions and zinc atoms in the experiment 3 is higher than experiment 1. Okay. So this one got 6 points, but maximum is 5 marks only. So total is 10 marks. Okay, total 10 marks.